So, one-to-one, it's pretty much like the name says. One-to-one means one thing for one thing. So one-to-one function means one x for one y. And so these are the x's, the domain as it says, if you can read that. These are the y's, the range. This one thing goes to one thing, this one thing goes to one thing, but these guys both go to the same thing. So no, it's not one-to-one. It's as simple as that. You don't want two things going to one thing. That's 2-to-1 instead of 1-to-1. So it's as easy as that. These first 15 questions are all super quick. Most of them are yes. So let me show you. So I'm just going to write 2, 9, 3, 6, -8, 3, 6, -8. So, okay, so, I just wrote a vertical. It's a little easier vertical. One thing to one thing. So there's no repeating. What would repeating be? It would be like if there was 6 and it also went to 7. That'd be the same thing going to two different things. That'd make it a no. Something like that. Or if you had, yeah, you get it. So this one's a yes. This one's, yeah, one thing to one thing. Right on through. Function. What's the test on a graph for something being a function? Vertical line test. Well, now we're going to also bring in the horizontal line test, which will test that it's a one-to-one function, right? They already said it is a function, meaning they're saying we know it passes the vertical, meaning every vertical line only hits 1 point. If you had an equation graph like that, that would fail the vertical line test and not be a function. They're saying to us, look, it is a function. We know it passes the vertical line test. We're asking you, does it also pass the horizontal line test? Does this one also pass the horizontal? Yeah, every horizontal line only hits 1 point. So that makes it one-to-one. That's what vertical and horizontal line tests do, is make sure there's not two hits on any one height or, X or Y, So yeah, that was good. Know the answer. So does that one pass the horizontal line test? No, clearly not. Boom, boom. No. So do you see what the problem is? Oh, yeah. They're supposed to put yes on top, aren't they? All right. So it's a no. So yeah, do you see what the problem is? That would mean pick any spot you want. How about this one right here? These two dots. What is that? That looks like it's over 1, down 2, and that's back 1, down 2. See, that's the same y value, right? Same y value connected with two different x values, huh? That's not one-to-one. That's why a horizontal line test shows it's not one-to-one. All right, so that's an inverse function. So let's see what they mean. So where they're taking this is the inputs, or the x's. This is the outputs, or the y's. And what we're wanting to do here is switch x's and y's. Switching inputs. That's what an inverse, which is what we're into now, inverse functions. Inverse functions are those where you invert x and y. You invert inputs and outputs. You just switch them. So, which one has been switched? Oh no, I guess I did the other one. Yeah, oh yeah, because this is going with Hannah. 162 doesn't go to Hannah. It goes to Carly. So this one's right here. Like that. So this is the right one. They just switched the x's and y's. And then they say, what's the domain? Remember, domain is the x's. Range is the y's. For the inverse, this is the inverse function here. That's how we write inverse. This is the inverse function. They're saying, what's the domain of the inverse? Well, they want this. So that would be B. Does that make sense on that? So the domain, next question is off the screen. They're going to say, what's the range for the inverse? Well, it's going to be all that. Domain and range, which is switched from the original function, huh? The domain of the original function is the names. That's the range for the inverse function. The range for the original function is the points. That's the domain for the inverse function, because that's what happens with an inverse function. You switch x and y. You switch domain and range, don't you? We're going to use that in about 15 minutes. So remember that. That's a switching of domain and range when you go to an inverse function. X's and the y's. That's what an inverse function is, an inverting of x's and y's. So I'm going to write it vertical. I just think it's easier to look at. -4, -5, -3, -13, -2, +13, -1, 12, 0, minus. So now, these are x's, these are y's, domain and range. For the inverse, you just invert them. So this becomes -5, -4, -13, -3, 13, -2, 12, -1, -12, 0. Just switch them. So whichever one does that is a B. There it is. B. Good? Just that simple. Just didn't bring the meat of it yet, but getting closer. Okay, so now they're giving me a function, f of x is 2x minus 1, and then g of x is a half x plus 1. So, what do they want me to do? Well, first off, they want me to do the composition. That was last night's homework, right? Composition, plug in one function into the other. We can do that. So they want f of g of x, they say right there. F of g. So that means put g into f. Remember, it's always right to left with functions, huh? So that means g plugged into f. So they want me to take all of g and put it in right there into the insert slot, the holes in the toaster for f. Okay, we can do that. So that will equal 2 times whatever minus 1. That's how f works, right? And what is that g? A half x plus 1. Is that good so far? I just plugged all of g into the insert slot in f. Now, what happens from there? 2 times a half, those just cancel, huh? Half of 2 is just 1. It's just 1, so it's really gone. So we just have x plus 1, and then the minus 1. So it's just x. That means f of g of x is just x. So that's the answer I gave right there. It's just x. But that one's g of f, huh? Whatever, same thing. It's just going to be x. What does that mean? What does that mean? If you take x, think about the significance of this for a second. If you take x and put it in the G machine, whatever x is, I don't know, but it's whatever it is, put it in the G machine, it pops out changed, I'm sure, and then goes into the F machine and comes out the way it started. Not the same thing. Right? Think about that real life. If I said, I got these two machines sitting on the table here. I got these two machines. I got this machine, call it the G machine. I got this other machine, called this. I'm going to take something. I'm going to take whatever. I'm going to take a piece of bread, and I'm going to put it into the first machine. It does something to it, pops out, and goes into the second machine. And when it comes out the other end of the second machine, it's back to the way it started. It's back to bread again. That's what this is saying, right? Started out X, went through both machines, came back to X. Oh, they're the inverse of each other. They're the inverse. They're undoing each other, aren't they? Whatever the first machine did to it, the second machine undid because it came back the way it started. That proves they're inverse functions of each other. They're undoing each other. They're doing the opposite of each other, aren't they? And that's how they have you test that. Basically, when the answer comes out X, that means F and G are inverses. They're inverse functions of each other when you just get X. And look at them. They are, huh? That's times 2 minus 1. This is times a half. It's opposite of 2. Add 1. They're the opposites. Those are inverse functions. They're undoing each other. They're doing the opposite of each other. So yeah, so that's what's going on there. So when you do that, and by the way, when you get X one direction, like f of g is X, when they ask you to do the other direction, they say, what's g of f? You just save some time, guys. It's always going to be X as well. If it's X one way, it's going to be X the other. Normally, when we switch g and f, it makes a difference. Normally it does. But if it's just coming out X, well, then it's going to come out X the other way too, because they are inverse functions at that point. So it doesn't matter which way you do it, you're going to get X. So they'll ask you both. So if you get X on one of them, you know it's X on the other. And then finally they'll say, what's the domain? There's no domain problems on this one, because there's no square roots and there's no denominators, right? Those are the only two areas of trouble we look for domain. You with me on that? If there's square roots or denominators, we don't have any, so it's just everything's fine. No values should be excluded from the domain. You can plug anything you want into those functions. They've got no problem areas. All right. Stop. So I should do that. So yeah, so first off, yeah, if I put G into F, G into F, it's going to be something cubed minus 7. What's it going to be? G, what is G? Cube root of X plus 7. Good so far? Just put all of G into F. Now, The third root and the third power cancel. X plus 7 minus 7, no surprise. There it is, x. So don't even bother to do the other direction. It's going to be x as well. So they're inverses. Okay, great. Now, what about the domain question, though? Because they will ask that next. What's the domain? Well, what have we learned about domain? Two problem areas, denominators and square. Two roots. Third roots are not a problem. No problems. I want to make that clear. I don't know if I've said that clearly before. Why? Why are third roots not a problem? Because, well, first off, why are two roots a problem? And then we'll see.
You can always get positive.
Yeah. Think about square root of -9. You can't do that, huh? That's imaginary. Because there's no number times itself twice that's -9, right? -3 times -3 would be +9, not -9. There's no number. But you could do the cube roots of negatives. That's fine. What's the cube root of -8? What times itself 3 times would be -8? -2. No problem at all. So you can have an odd number of minus signs. An odd amount of minus signs becomes minus, doesn't it? So we've got no problem with third roots. They're not a problem. You can put negatives in there. No problem. But you can't put negatives in a 2 root. So when they give us a question with third roots and they ask us about domain, we say do whatever you want. No problem. We don't do the inside greater than or equal to 0. It's only for 2 roots. Only for 2 roots. That says inside. Where we say inside, you have to be greater than or equal to 0. Only for 2 roots. Only for 2. Good? Not for odd roots. Odd roots, no problems. On the graph for an inverse function. What's the graph of the inverse of that blue graph going to look like? Mirror image, mirrored across what line?
That line.
That line. The y equals x. Yeah, it reflects it across the diagonal line. Let's see it. If I just remember what an inverse function is, it's an inverting of inputs and outputs, x's and y's. So let's take x, y, -4, 1, and switch them to be what? 1, -4. That'll be on the inverse function, right? The inverse of all the original ones. So let's switch those and let's find that point. Where's the point? Over 1, down 4. Over 1, down 4. It's right here. You with me? Mm-hmm. Now, let's take 1, 2, and invert that. That'd be 2, 1. Let's find that point. Over 2, up 1. It's actually right there, isn't it? So there's 2, 1. Let me connect those dots. See what's happening? Let's take 2, 3, and inverse 2, 3, it'd be 3, 2. That'd be over 3, up 2. It's right there. See what's happening to the graph? And finally, when you take -5, -5, and you reverse them, nothing changes. So that's right the same spot. There it is. See how the inverse graph is just a mirror across the diagonal line? Because when you switch x's and y's, you're jumping straight across the line. What is that line? Y equals x. That's the line where y values equal x values. Everything on that line, they're equal. So when you switch x and y, you jump directly across that line. That's what's happening. All right, so that'll be no more graphs. Well, we'll have graphs too, but now actual equation. So they're giving me f of x equals 4x, and they want me to find the inverse formula. So how do you find the inverse for a formula? You know, if you just have table, you just switch x's and y's. What do you do for a formula? Well, same thing at first. You invert or switch x's and y's. Number 2, solve for y. Does that make sense? So you just switch x's and y's and solve for y. Because that's what an inverse function does, right? Invert x and y. So switch x and y. Now, when I say switch x and y, where's y? I don't see y. Where's y? Yeah. Remember, function values are y. So here, I'm kind of scribbling it all up terribly. Let's just do it like that. That is y, right? That f of x or g of x or h of x, any function letter is y, isn't it? So that is y. So when I say switch x and y now, That really means they just trade roles. Everything else stays put. So the 4 stays where it's at. Anything else in the problem stays right where it's at. Just all the x's and all the y's magically switch roles. Just like that. Because that's what an inverse function does, inverting of x and y and their roles. Now, so that's step 1, invert x and y. Step 2, what do I do now with this? Solve for y. How do you solve that for y? That's pretty easy. Starting us off easy here. Divide by 4. There it is. There I solve for y. There's the inverse function. What is the inverse? X over 4, which is what I answered right there. The inverse is x over 4. And that makes sense, huh? What's the opposite of multiplying by 4? Well, dividing by 4. That's the inverse. They're going to get much harder than this. We could have just guessed at that one, huh? Good. We didn't need a bunch of steps or anything. Now, they want you to graph them both. You guys comfortable with graphing?
Yeah, just put it on a calculator.
Okay, but I could put this on part 1. I hope you can also graph this one by hand. So let me go to the original. Y equals 4x. How would you graph that? It's a line, huh? Plus 0. You start at 0. And the slope is 4 over 1. Go up 4 over 1 like that. So that'd be the graph of the original. And now how do you graph the inverse? Inverse over here is x over 4. How do you graph that? Well, again, plus 0. So start at 0. And the slope is 1 over 4. Rise over run. Go up 1 over 4. So there's 2 dots for him. Connect those 2 dots. So this is the inverse graph. And this is the original graph. Like that. And notice they are a reflection across the diagonal line, aren't they? That good? Graph in 2 lines? So which one is that? Is it B? It looks like B, huh?
No.
What is it? C? They're close.
B isn't on the origin. Is it on the origin?
Oh, B's not on the origin. Good. Oh, C's not either.
It's B.
Oh, it's D. It's off the screen. All right, whatever. We'll move. Okay. Now we'll slow down a little bit. So number 19. All right. So they give me a function x cubed minus 8. X cubed minus 8. And they want me to find the inverse function. So how do I find the inverse? Remember the steps for the inverse. 1, switch or invert. X and y. Step 2, solve for y. So switch x and y, solve for y. So let's do that. So I'll trade roles here. This will become x. This will become y. Good. Now, how do I solve that for y? Y is saying I want to be alone. There's the wall. I want to be alone. So, yeah, move that, add that 8, or jump that 8 either way. It becomes x plus 8 equals y cubed. Good. Now what? How do you turn that into a plain y? I don't want y cubed. I want plain y. What'll do that? Cube root, huh? Cube root cancels third power, so it's y equals cube root of x plus 8. That's it. That's the inverse function. That's what goes right there. Now it looks like the opposite, doesn't it? Cube root of x added 8 versus third power minus 8. Yeah, those are opposites. There we go. Okay, now they're going to ask a bunch of domain range questions, so let me help you with that too. But everybody got that down? Questions to that point? Yeah?
Would multiplying the whole thing by 1/3 do the same thing?
Oh, good question. No, not quite.
Or to like the exponent, I mean.
Yeah, with you. Yeah, that's totally right then. Yeah. 1/3 power? Totally. 1/3 power. Yeah, 1/3 power is the same as third root. We'll get more into that, well, probably next week. Yeah, definitely, because we'll do powers. Yeah, so it's good if you already know that. Those cancel. That's the same thing. A 1/3 power is exactly the same as a third root. It's 2 ways to say the same thing. I assume, oh no, they say use radicals. So they want the radical thing. They don't want the 1/3 power. Do you see that? That's just their style desire on that one. So, all right, so now we got to do all these domain range questions. Let me show you a super easy way to answer all the domain range questions. So we got this right. So let me go to a fresh screen here. Okay, coming back. So we got the original function, x cubed minus 8. Let me write them both down, and we'll do them both. So the original function x cubed, or I'll just call it f. The original function f is x cubed minus 8. Okay, and then the other one is cube root of x plus 8. Okay, So over here, so f inverse is cube root of x plus 8. Okay, now what we want to do is find the domain. Let's start with the domain. All right, what's going to be the domain for x to the third power minus 8? Yeah, no problems. Huh? There's no denominators and there's no square roots. That's all we look for, problem areas. So all reals, everything's fine. Okay, now let's go over to the right side and find the domain of the inverse function. What's the domain of him?
All reals.
Again, no problems, all reals. Because remember, third roots are fine. Odd roots are not a problem. If that was a 2 root, I would say inside, greater than or equal to 0, and solve, huh? But for odd roots, no problems. Now, how do we do range? Trade them. Right? Because remember, this is what I said it's about 15 minutes later. Domain of the original function becomes range of the inverse. And domain of the inverse is range of the original. Remember, domains and range trade? That's what an inverse function is. Trading of x's and y's, trading of domains and ranges. So therefore, this domain goes over here and becomes his range, which is all reals. Everything's all reals on this one. And his domain, it'll be more useful later when they're not just all reals. But that's how we're always going to handle that. Just find the domain for both, trade them. It's the range for the opposite one. Because that's what an inverse function is, trading of domains and ranges. So it's just all reals for everything on that one. But in a bit, it'll be more interesting than that. Is that good? All right, let's try it out. So f of x, the original function, is 4 over 6 plus x. Find the inverse. Let's start by just finding the inverse. So let me let you do it. You get more out of it than if I just do it real quick. So you know what to do, right? This is y over here. This is y, isn't it? So just switch x and y, solve for y. All right? Switch x and y, solve for y. All right, so switch them. So switch x and y. So this will become x. This will become y. Good so far. Now we have to solve for it. How do you solve when you got like fractions? What do we always do? We got fractions. Multiply by the denominator, huh? That gets rid of the fractions. Same thing here. That's just the denominator is that. So multiply both sides. Got to do both sides. By that cancels it out there, so we don't have to mess with fractions anymore. So this is just 4 on this side. What's the other side? Well, that x will distribute. 6x plus yx. Good to there. So far, got rid of the fractions. Now I'm trying to, y is right here. Saying I want to be alone. Now it's solve for y. So that means jump the 6x to the other side. So yx is 4 minus 6x. And divide by the x. Exactly. Boom. There it is. That's the inverse function. Hey, can we cancel these x's?
Yeah.
No.
Why not? Top's glued. Remember, the Costco pluses and minuses glue things together. The top has a plus or has a minus. So that means if you want to cancel anything on the top, you go like that and cancel the entire top, or you don't touch it. It's all or nothing. It's glued together, so we just leave it as it is. If it was times, that was 4 times 60, we could totally cancel the x's. It's the pluses and minuses that glue it. All right.
Instead of distributing the x, couldn't you have just divided and then subtracted the 6? Or do you have to distribute it?
Oh yeah, no, you're right. That would have worked too. Yeah, good. Yeah, good point. Let me show that too. I like that. So we had 6 plus y, x is 4. Yeah, Seema, you're totally right. Could have just divided by the x there, boom, and then you had 6 plus y is 4 over x, and then jump the 6 to the other side, So y equals 4 over x minus 6. That's the right answer also. Would you recognize that? I'm glad you brought that up also, because on the multiple choice exam 2, week after next, what if you had this answer and the multiple choice option C or whatever was that? Would you recognize those are the same thing? They are the same thing. How do you know? Well, a couple different ways. You could just separate this one over common denominator, right? Like if you had this answer and you're wondering if this is the same, you could go, well, look, this is one big bar, separate it, and now these x's can cancel because now they're just times here. So they can cancel after you've separated them. So you see it's this. It's the same thing. It's a different way of saying the same thing. That good?
I could just make a table of them to make sure, right?
That's true. You can make a table. Sometimes that takes a little bit of time, but yeah. Okay, good. So we got the inverse. Let's do the domain range stuff now. So we all good with the inverse. So we have the inverse function two different ways. Either one is fine. Okay, so now, fresh screen here. Let's do the domain range part of it. So the original function, f, is 4 over 6 plus x. And then the original is 4 minus 6x over x. Okay. Inverses. Or the other way. Either way, it doesn't matter. You can use it either way there. Okay, so let's start with domain over here. What's the domain of the original function?
X cannot equal -2.
Yeah, x cannot be negative, right? Because if you put in -6 here, that would make that bottom 0, right? We can never let the denominator be 0. So x cannot be -6. Guess what that's going to be? Well, let's go over here and do the domain for the other one first off. What's the domain for the inverse function? Denominator cannot be 0. And then what do? Trade it, right? So range for the original, x cannot be 0. Range for the inverse over here, x cannot be -6. How they just trade? Oh, yeah, thank you. You're supposed to say y for the ranges. That's right. I always forget that. Y. Because range is y values. But it's the same numbers. It's exactly the same numbers. And we're done. Is that okay? Well, that just find the domain for both, trade them. All right, got a couple more messy ones. All right, 22. So there's the function. F equals 8x over 9x minus 5. That's really y, as you know. So let's find the inverse, which you know means step 1, switch x and y. Step 2, solve for y. Good, so step 1, switch x and y. Step 2, solve for y. So go ahead, give that a try. So that means both x's become y's. You know what I mean? Everything else stays put. They just trade roles. This x, or this y literally becomes an x, and both those x's literally become y's. Y and x just trade roles. Everything else stays put. Now, that's step 1. Now solve for y. That's a little more tricky. I want you to try it and see what I mean before I finish it. You get more out of it, I think. So try that. It's a little bit tricky. Multiply by the denominator, like usual. Multiply by 9y minus 5 both sides. Cancels here. So we get so we get 9y minus 5 times x is 8y. Yeah, here's a case where you don't really want to divide by that x. Like it worked nicely on the last one. This one it would, well, I mean it wouldn't be. Yeah, it would be kind of a pain. Yeah, you really want to distribute that x. It's just going to be a little easier. 9xy minus 5x. Okay, so we're good to here. This is where a little trickery comes into play. Is everybody good to there? We're trying to solve for y. So can I just go divide by 8? There it is, y. No, the problem is there's another y over here. You see the issue we're having? Y is in 2 locations, isn't it? So that's going to happen. For sure there's one of these on the exam week after next. I just think these are so valuable for calculus. You do this all the time in calculus. So for sure, and you'll see there'll be like the next 2 or 3 homework problems will also do this. So it's really important in homework, certainly be one on the test. So let me give you specific help with it. So when y is in 2 spots, when y, that's what we have here, right? Y is in 2 spots, these 2 spots, what do? Number 1, get the y's on the same side. And step 2, factor out. It's kind of weird, you don't expect to factor. Factor out y and divide. That's the game plan. This will happen a lot in calculus, as I was saying. So, get the 2 y terms on the same side. What do I mean? Grab that whole y term and jump him over there so that both the y terms will be together on the same side. That's the first step. Get them on the same side. So we got minus 5x is 8y. Remember, when something jumps to the other side, it changes signs, right? That was really a plus 9xy over here. In front of it was nothing, which is plus. Jumps over, now it's minus. Okay, now the 2 y terms are on the same side. Now what do? Factor out. Factor out. That's how you get y to be in only one spot. It's by factoring. Everybody see that? We factored it out. Now divide. Divide by the 8 minus 9x. There it is. Y is alone. That's the inverse function. There's our answer. Is that good on that? Questions on that? And you can find the domain of that, right? Bottom not equal to 0, solve for x. Domain of the original, trade them for the ranges. It's okay if I just skip over that? Well, I would like to do another one of these messy ones with the little bit of time we have left. Good to there? Questions on that? So that's real important. Real important. For sure on the test. Okay, so y equals 8x plus 4 over 9x minus 7. Okay, same thing. Find the inverse, switch x and y. Step 2, solve for y. So you're going to have the same issue. See, we have 2 x's, so when we switch, we're going to have 2 y's, huh? We're going to have y in 2 places. So you need to do the same thing. Get the y's on the same side, factor out the y, and divide. X equals okay, you guys getting it? Multiply by 9y minus 7. Cancels out. Am I good? And then this x is going to distribute 9xy minus 7x equals 8y plus 4. Good to there. And now, what do? So we, y in 2 spots, get on the same Get y on the same side, huh? Get the y's on the same side. So this has got a y term and that's got a y term. And then the other two don't. So you got a couple of things to rearrange here. So I'm going to grab this one and go this way, and this one and go that way. You could switch out. It doesn't matter where you get the y's, right side, left side, whatever. Just get the two y terms on one side, the non-y stuff on the other side. So what do we get there? We get 9xy minus 8y, 7x plus 4. Is that good so far? Things trade signs when they trade sides. So I got the two y terms on the same side. Step 2, factor out the y and divide. So factor out the y. And last step, divide. And there we go. That's the inverse function. That making sense? Huh? Think you could do that on the next test? Questions on that?
How many questions?
From 5.3? A lot, and they're all hard. It's a lot harder than this section. Yeah, so it's 5.4. We have 2 sections left to go. We're getting a little squished for time. We're probably going to move the exam back one day. It'll probably be week after next Wednesday, Thursday. Yeah, I'm sure it will be. All right, so let's do this one and we'll stop. Y equals x squared minus 2 over 5x squared. Same kind of thing. Find the inverse. Let's try this one. Be a good one to wrap up with. So switch x and y. Solve for y. In 2 minutes. Can you do that? Switch x and y. Solve for y. So x here. Good there. Then multiply by the denominator. So multiply both sides by 5y squared. Boom, like that. It's gone. So then we get 5xy squared is y squared minus 2, like that. You good? Now we got y in 2 spots. Y in 2 spots. What do? Get the y's on the same side. Factor out y and divide. So get this term, jump it over. So 5xy squared minus y squared is minus 2. Good to there so far? So get the y's on the same side. Next, factor out the y. Good to there. And divide. So I got to divide by 5x minus 1, 5x minus 1, boom. Now that's y squared. We're almost done. We're very close. We're over here. So this is, or maybe up here, y squared equals what? Minus 2 over 5x minus 1. Just bring it up here. What's the last step? Just square root it, yeah. Square root it, boom. There we go. We got y alone. There it is, square root of negative 2 over 5x minus 1. What's that?
You have to clean it up the answer.
No. Whoa, because it's a root in the bottom?
Yeah.
I don't know. I hope not. I would think that'd be fine. What's that?
On the exam fees there.
Well, it's multiple choice, so as long as you can recognize. Yeah. All right, guys, we're done. 5.2 is due on Monday. Have a good weekend.